Good morning, my dear students. In today's class, we will discuss very important concept of the chapter structure of atom, or it is atomic structure, and obviously it is class 11th. The topic which I'm going to discuss, it is very important for class 12th as well class 11th. Here in this platform, we will learn how we can manage, how we can frame the electronic configuration, means filling of electron in various subcell using certain or using important trick like the pyramidal structure. We are going to use in this lecture the pyramidal structure, or we can say the triangle structure, and with the help of this we can easily conclude any electronic configuration of any kind of atom, any kind of element, whether its atomic number is less than 10 or more than 100 or in between 10 to 100, means any atomic number we can discuss here. So what is electronic configuration? Electronic configuration is nothing but it is systematic arrangement of position of electron in subcell, shell, orbital. We can say again, the arrangement of electron in various cells or next subcell and next to orbital in an atom is termed as electronic configuration. Means it is nothing but the configuration of electron. With the help of this we can locate the particular place, the particular position of that electron in an atom using that concept electronic configuration. So students, just here one question, and with the help of this question, because this question we already discussed in my previous class, and again we are going to solve this because this is very important concept, and after that we will discuss this pyramidal structure. Correct now? So check NLX. What is N? N is nothing but number of shell, and next to cell it is subshell, means L is number of subcell, and number of cell is nothing but principal quantum number, and number of subcell is what? Azimuthal quantum number. And what is X? X is number of electron present in that particular subcell. So example 4px1. What is 4px1? What is 4? 4 is nothing but the number of shell, that is 4. It is also known as principal quantum number. Next, for P subcell, there are 3 orbital, number 1 px, number 2 py, number 3 pz. So for the value of azimuthal quantum number for px subcell, it is px, basically px is orbital for p subcell, because L is representation of subcell, means for for p subcell the value of azimuthal quantum number will be 1. Next is what? Magnetic quantum number. And students, magnetic quantum number related with orbital, and for p subcell there are 3 orbital, as I discussed just px, py, pz, and the value of pz is fixed. It is what? It is 0 always, but here it is not pz, that's why we can write either +1 or -1. And the next is ms. Ms is what? Spin quantum number. So because of one electron is there, either it can revolve upward direction or next downward direction. So it can be ±1/2. Students, we discussed this topic already in my previous video lecture. So what about shell, subcell and orbital, and the position of electron in an atom? Something like this. With the help of quantum number we can justify. Correct now? So next is electronic configuration. We use triangle. What is S, PS, DPS and FDPS? Is nothing but subshell. What are S? What is P? Because we know now we have 4 kind of subcell: S subcell, P subcell, D subcell and F subcell. So students, just remember school, public school, Delhi public school and foreign Delhi public school. One Delhi public school in I think Ukraine or Uganda something. So it can be also foreign DPS, means foreign Delhi public school. Again I am repeating: school, public school, Delhi public school and foreign Delhi public school. Correct now? Just make a copy of this triangle next side. Okay. So again it is school, public school, Delhi public school and foreign Delhi public school. So just do this one for this thing 2 times, this triangle and this triangle. Now how we will move like S, then again S, star mark. So next star will be start from here, then P, then again S, P, then S, then again 2 star. So 2 star will be start from here, D, P, then S, D, P, then S. Means we will move left to right. Suppose we are here, to means next we will here. Correct now? Suppose next S is end here. So we will move from this side, FDPS means we will move left to right. Students, maximum number of electron in SPDF subcell, we have formula for L plus 2 now, and the value of L for different subcell, it is 0, 1, 2, 3 for SPDF respectively. Means the value of subcell for azimuthal quantum number, or we can say the value of azimuthal quantum number for SPDF subcell, it is nothing but 0, 1, 2, 3, or we can learn SPDF as soft PDF, and the number of soft PDF is what? 0, 1, 2, 3 means 0, 12, 3 or 0, 123, whatever it is. Correct now? So how we can fill it? Very important. Correct now? So students, the number of S subcell is nothing but number of K shell. So it will be start with 1. To just write continuation with S means 1S, then next 2S, then it is 3S, next is what? 4S, then again it is 5S, here it is 6S, here it is 7AS, and here it is 8S. Any problem? Just pick S subcell. Okay, after S we will start P, and the number of P subcell, which is just equal to number of L shell, that is 2, means P will start with 2. So 2P, here 3P, here it will be 4P, 5P, then it is 6P, and next last it is 7P. Okay, what about D? The number of D subcell, it is equal to number of M shell, and number of M shell, it is equal to 3, means D will start with 3, and next D it is 4, it is 5, and it is what? 6. Next what? F. The number of F subcell, it is equal to number of N shell, and the number of N shell is what? 4, means F will start with 4 and finish with 5. Done? Nothing but 1S, 2P, 3D, 4F. The minimum number of S is 1. The minimum principal quantum number for P is 2. The minimum principal quantum number for D is 3. And the minimum PQN means principal quantum number for F, it is 4. Correct? In this manner you can continue. So now we are going to discuss the first 10 element with their electronic configuration. Okay, and remember students, the maximum occupancy of S subcell, it is 2 electron. For P subcell it is 6 electron. For D subcell it is 10 electron, and for F subcell it is 14 electron. So next is hydrogen to neon we will discuss, and next 11 to 30 or further we will discuss in my next video class. So you have to wait for rest element, but still here we can discuss at least little, so that we can make our concept very much strong regarding this topic. So here check. Hydrogen, its atomic number is 1, means it has only 1 electron, and 1 electron, for 1 electron I will choose S subcell, because first I will start from here students, and I will finish with 8S. So the maximum electron which can occupy by S subcell, it is 2, but it has only 1 electron. That's why I will write 1s1, or 1s1 can be written as like this. Correct? It is Hund's rule. For helium it is 2, atomic number 2, means it has 2 electron. Done? And 2 electron, it is what? 1s2, because maximum I can occupy 2, so no problem. So So means according to above rule, according to Pauli rule, according to Hund's rule, or generally we discussed about Pauli exclusion principle, where it is stated as the maximum number of electron which can occupy in an orbital, it is 2 with opposite spin. So you have to take care of spin also. So that we just write like we just written like one electron in upward direction and next is downward direction. Now it is important to lithium. Its atomic number is 3, means it has 3 electron. Z is atomic number, correct? So first I will start from here. 1s2 done, and remaining one will move to where? 2s, means 2s1. Now collectively they are 3. So because 1s2 is the electronic configuration of helium, so we can also write helium in place of 1s2, and next is 2s1. Done. Check beryllium. Here its atomic number is 4, means again it has 4 electron. So 1s2, 2s2. Done. So 1s2 can be written as helium, and next is 2s2. Next, boron is important again. Boron, atomic number of boron is 5, means it has 5 electron. So 5 electron, again we will start with 1s. So 1s2, 2s2, I use 4 electron out of 5, means next remaining 1 electron will enter into P, because after filling this I will come to this line. Okay, so for boron 1s2, 2s2, 2p1, means for 1s2 it is helium, so 2s2, 2p1, or we can write like 2s2, 1s2 for helium, it is 2s2, and check here it is 2p1. Okay, here 1s2, 2s1, here 1s2, 2s2, here 1s2, 2s2, 2p1. For carbon, because I have 6 electron, so 1s2, 2s2, and next 2 electron will enter into 2p shell, means 1s2, 2s2, 2p2, or in place of 1s2 we can write helium, and helium is what? 1s2, means next 1s2 it is 2s2, and next is 2p2, and as per Hund's rule I will follow that rule, and according to that rule helium it is 2s2, and 2p electron I will not write in the pair form. I will fill one electron in each orbital, so that after the half filling of each orbital I can go for pairing of electrons. So check nitrogen and oxygen. Nitrogen atomic number 7, 1s2, 2s2, I use 4, means still I have for nitrogen 3 are remaining, so it is 2p3. So check 2p3, or it can be helium 2s2 2p3, or it can be written as helium 2s2 2p3, means 1 2 3, means it is compulsory to fill each single electron in an orbital until the half filled orbital, until the each orbital is half filled completed, means its half filled tendency is complete. We will fill single electron in each orbital until it's become half filled. Okay, each orbital it's become half filled orbital. So next for oxygen pairing will start. Check 1s2, 2s2, 2p4. I have 8 electron, so 1s2, 2s2, 2p4. So we can write helium 1s2, 2s2, 2p4, 2p4, 1, 2, 3 and 4 electron will pair. So this electron which is downward motion, it is what? Last electron, and it is also known as 8th number of electron, correct? So it is very important. For fluorine 1s2, 2s2, 2p5 we can write like this, and for neon 1s2, 2s2, 2p6 we can write like this. So students, it's all about electronic configuration of first 10 elements. In my next class we will see how we can manage next 30, means we discussed 1 to 10, means we can take example till 30 or till 35 electronic configuration, and next at that time after the discussion of that element you are eligible, you are now active for the completion of all electronic configuration of all the elements which are situated at periodic table. So we will meet next time and we will discuss next electronic configuration for next upcoming elements. So till then, thank you a lot.